In this video, we're going to take a look at three Leetcode problems: combination sum, number 1, and number 2, and number 3. So these are all really popular backtracking problems. So let's take a look at them. Start by combination number 1. So for this problem, we're given an array of distinct integer values, right? And then we also have given a target integer value. We're asked to return all the unique combinations from the candidates array, and we can return them in any order. So we can have this, we can use the same number of times. So here you can see we have an example of array and then a target. So we can have 2, 2, 3, which add up to target, and we can also have 7 itself. So there's no size limitations of how many elements we need to have in the array, and basically in total we have two distinct combinations. Of course, we can have 3 plus 2 plus 2 or 2 plus 3 plus 2, but that won't work because we want unique combinations, right? And therefore we have to get all the distinct combinations, right? And it doesn't matter if we return 3, 2, 2 and a 7, right? Or 2, 3, 2 and a 7, right? What it matters is we need to have all the distinct combinations. So here you can see we have another example of 2, 3, 5. So we can have 4 2s and 1, 2, or we can have 2, 3, 3, or we can have 3, 5, which add up to 8, right? So there's a couple more examples here, but you get an idea, right? So how can we solve this problem? Well, to solve this problem, what we're going to do is we're going to draw the recursion tree out. So to solve this problem, I think it's very important to draw the recursion tree out. And once we draw the recursion tree out, the way how we solve this problem is more clear. So in this case, we're starting with an empty combination, right? In this case, our current combination is empty. Then we can have 3 paths to take because we have a total of 3 candidates. We have 3, 4, 5, and we can reuse the current element as well. So in this case, we can add 3. So now we add 3 to our combination, and now we have 3 decisions as well because, like I said earlier, we can be able to add our current element as well. So we can add 3 or add 3. We can take this path, and we can also add 4 to take another path, and we can add 5. So in this case, we're going to do depth first search. So let's stick to one path. Now, if we were to add if we were to add 3 onto it, now we have a total of 6. The target is 8. So in this case, within our depth first search method, we need to define our base case, right? In this case, our base case is pretty straightforward. We know that 6 is less than target, so we have rooms to search. Okay, so let's continue. Now let's say we have 3. We add one more 3, right? In this case, if we were to add one more 3 or 4 or 5, it doesn't matter. But if we were to add 3, we exceeded the limit, right? In this case, we have 9. So in this case, what it means is that if we have a sum that is bigger than the target, then we can just stop our searching from there, right? In this case, because the sum is 9, the target is 8, our sum is bigger, so there's no way that we're going to get this combination if we were to continue searching this path. So now we're going to go back, right? We backtrack to here. Now we try with a different combination, right? Because if we were to backtrack to here, there's no more combination because in this case, 3 is the smallest among those elements, right? The first element. And then we know that 3 in this case is already exceeded the sum. So we backtrack again. Now we're here. Then we can take the 4 path, right? The path 4. In this case, we add 4 to the second element, and we now know that this is 7. 7 is still less than 8, so we thought we have room to continue to add elements in the candidate. What is it called? The combination. Then we can continue to either add 3. If we were to add 3, right? In this case, then we will exceed the sum, right? In this case, we have something like 10. So it's bigger than 8, so we backtrack. Doesn't matter which element we add, we will exceed, so we backtrack again to here. Now we have 3, 5. We know that 3, 5 has the sum of 8, 8 is equal to target, we can just add the current element, current combination onto the result list. And then at the end, when we compute all the paths, we can just return the result list, right? And the goal is that for next path, you can see 4. You notice that we don't have any 3 anymore. Like we don't have 3, 4. In this case, because we already have 3, 4 here, right? So in this case, we cannot have 3, 4 here. Or I should say, we cannot have the path 3 because we already completed the path 3. So we're done with that, so we don't have to do it here. So that's how we like getting no duplicate elements. Sorry, not duplicate combination, right? Because I can have 4, 3, I can have 3, 4, right? So in this case, if we were to do it like this, we can ensure that there is no duplicate path, or I should say no duplicate combination. So now you know how to do it. Let's try to do this in code. So to do this in code, what we're going to do is we're going to have a global variable. So let's create this global variable called list of list integer that we're going to return at the end. Okay, so then what we're going to do is we're going to basically pass down this candidates and also make that as a global variable. Right, so we don't have to pass them down each and every single time, right? It's going to be a lot easier. So we're going to name it nums. And I guess we can just declare it here. So it's equal to candidates, right? In this case, what we're going to do is we're going to first have a combination, which is a empty linked list, right? The current combination that we have, right? And then what we're going to do is we're going to have a current starting point, which is 0. Then we're going to pass in the sum, right? Initially, we have a sum that is equal to 0. Once we've done our depth first search, we're just going to return the results. Okay, so let's try to create this our DFS method, which has a combination list, current combination. We're going to have our current index integer as well as the current sum. Okay, then what we're going to do is we're going to filter, right? We're going to do our base case. So if we have our sum, right? If our sum, one thing I forgot to do is we have to make our targets. In this case, let's create a target variable and just assign it to target here because we're not changing this target variable that much, right? So in this case, so that we don't have to pass this target variable every single time. So what we're going to do is that if sum, right, in this case, if sum is actually bigger than target, then we can just return, right? And if the sum is equal to the target, then what we're going to do is we're going to add the current combination onto the result list. So result.add a brand new array list. We're going to pass in the combination. The reason why we do this is because when we do in backtracking, right, in this case, this combination, if we were to just pass in this combination like this, right, this variable will change, right, because in this case, this list is reference type. So what we need to do is we need to save the current data onto a brand new list and then add it onto the result list, which is what I did here, right? Then we're just going to return because our job is done. Now, what we're going to do now is we're just going to iterate, right? Iterate our options. So in this case, we're going to start at current index up to the end of the array. So we're just going to add the current element onto the combination, and then we're just going to increment the sum. When we pass down the depth first search, we're going to get the sum plus the current element, right? And once we coming back from the depth first search, once we've done the depth first search, we're just going to redo the changes that we made on the combination by removing the current element, right? I should say the last element that we added in the list. Right? So in this case, we're just going to have combination.add
nums at current index, right? So we're adding the current element onto the combination, and we're going to do a depth first search. We're going to pass in the combination, and we're going to pass in the current index, right? We're allowing duplicate values, right? So in this case, we're starting at the current index when we do a depth first search, right? It could be 2 plus 2 plus 2 plus 2, and target is 8, and we found our answer, right? So we can reuse duplicate values, but we're allowed to use duplicate combination, right? So we're going to have sum plus nums at current, not current index, my bad, I, right? In this case, it's going to be I all the way to nums.length. And once we've done that, we're just going to redo our changes by saying remove nums.length, sorry, combination.length for size minus 1, right? They're removing the last element that we added onto the list, right? So we're removing it off of the list for the last element that we added. And then we're just going to continuously do that until we get the job done, but we have to change this to I, right? We're not passing down the current index for the current index. We're passing down the index that we're on, right? So that we don't have any duplicates. I should say, yeah, no duplicates combinations, right? So let's try to run the code, and let's try to submit. Okay, so here you can see we have our success. So the other way we can solve this problem is we can use a hash set as well, right? So that's one way that I showed you. The other way that I try to do is we can use exactly what we did in permutation problem, right? The permutation problem that I did in my channel. And then what we're going to do is we're going to use a hash set that first we're just going to get the array, get the collection. Once we get the collection, we sort the collection, and then we add the collection onto this hash set. And then in this case, we guarantee that every time when we add a combination, it's going to be a unique combination. The question says it doesn't really matter what's the ordering of the, in this case, the combination. So we can just add it the way however we want it. So in this case, we can sort the array and then add it onto the hash set. And at the end, we're just going to turn the hash set into a list and then return that, right? So that's the other way we can do it. But the time complexity in this case for this problem is going to be exponential. So I don't really think for if we were to sort the array, we really make the time, because log-in time complexity is still faster than the exponential, right? So in this case, either way works in my opinion. So now you know how to solve the combination sum 1. Let's take a look at number 2. So we're given a integer array this time and then a target. We're asked to find all the unique combinations that we can have that the sum is equal to the target. So each number in the candidates might only used once in the combination. So the solutions set must not contain duplicate combinations. So we have this array right here, and then you can see we have target is 8. So we cannot have duplicate combinations. For example, let's say we have 1 7 here. We cannot have like another 7 1 because in this case we have an array that contains duplicate values. So we cannot have duplicate combinations, right? In this case, we have 2 6, 2 here, and 6 here. And you can see that we can have 1 2 5, right? But we cannot have 2 1 5, right? There's 1 there, and we cannot have duplicate combination. So to solve this problem is very, very similar to how we did in combination sum 1. Right? One way we can do this is we can use a hash set that I talk about, right? Every time when we found a combination, we have a hash set that keeps track of the combinations that we have, right? All the combinations that we have. For each time when we find a combination, we're just going to sort the array, we're just going to sort the list, sort the combination, then we're just going to add it onto the hash set. And by the end of all the combinations that we've done, we guarantee that all the combinations that we have in our hash set are unique, and we can just convert the hash set into a list and return that at the end. That's one way. I already showed you that. But what we can do instead is we can first sort the array, right? We can sort the array. Once we sort the array, what we're going to do then is we're just going to do this, implement the same thing that we implement in the combination sum number 1. First, let's take 3 as the first element. We're going to go down and then say, well, for the second element, we're going to put 3 here. And then we're going to continue to explore all the options. The current element, right? In this case, the current element that we're adding onto the list. Let's say this element right here. We want to make sure that this element right here, let's say this element right here, because we cannot have duplicate, right? So let's say this element right here, we want to make sure that this element right here is not the same as the previous element, right? The previous element is going to be 3, so we want to make sure that it's not the same element, because in this case, let's say we have 1 1 1 1 2 5, right? If we were to go down the path and exhaust all the options for 1, we've done that. We have 1 1 6 for 8. We have 1 2 5 for 8. We have, let's say, 1 7 for 8. We already exhaust those options. And now if we were to have this element to exhaust all the options that we can have for this element, in this case, we're going to have 1 2 5 again, right? And we're also going to have 1 7 again. We're also going to have, let's see, we also can have, yeah, I think that's about it. But you get an idea, right? So what we can do is that we know that the first element has more options, has more path. So we can just take the first element and we can just ignore the second element after we do a depth first search for the first element, right? So in this case, what we can do is we can say that if current element is the same as the previous element, then we can just continue. We can just move on to the next iteration, right? So let's try to do this in code. We're going to do the same thing that we did earlier by having a global variable. Then what we're going to do is we're going to make this a global variable as well. So it's going to be nums. And then we're also going to have a target, right? So in this case, we're going to have a target that, in this case, we're going to have a target that reach to this point. Like we're going to have a combination that has a sum that is equal to the target, and then we're going to add it to the result list. So we're going to have this depth first search, passing our initial combination, which is empty list, and then we're going to pass in the current sum and the current index that we're starting at, which is 0. Okay, and then we're going to make the target as a global variable, just like how we did in the previous problem. Okay, then what we're going to do is at the end, after we've done depth first search, we're just going to return a result. So that's our combination, and then we also have our integer sum, our integer current index. Okay, so then what we're going to do is we're going to first declare our base case, right? So let's say we have our sum. So if sum is actually bigger than the target, then we could just return, right? Because it's bigger, then there's no more. There's not going to be anything that we can do. And one thing that I forgot to do is we have to sort the array. So in this case, we're going to have nums. So arrays dot sort nums, right? So then what we're going to do is we're going to say if sum is equal to target, then we're just going to say rest.add our current combination, and then we can just return, right? Our job is done if we found the element, right? So then what we're going to do is we're going to say we're going to create a for each element, right? For each element in the basically we're going to start at the current index. We're going to start at the current index because in this case we don't want any duplicates combination, right? So you can see here, like I mentioned before, the reason why we don't have any 3s, we only iterate 2 times here, is because in this case, we've done all the combinations that we have 3, right? So we cannot have like, for example, 3, 4 or 4, 3, right? Because that's going we already done that. So we don't have to include, we don't have to traverse, we don't have to include 3 in our combination or in our search. Well, I is less than nums.length. What we're going to do is we're just going to add in the current element onto the combination. Then we're going to pass the current combination, right, in this case, and then we're going to pass down the current index plus 1, right? The reason why we plus 1 is because we cannot reuse the current element again. So in this case, we're going to have combination.add current index, sorry, I. We're going to add the current element. Then we're just going to pass down the depth first search, pass in the current combination as well as the sum plus nums at I, right? And then the current index now in this case is going to be I plus 1, right? We cannot reuse the current element again. So after we come back, we're just going to say dot remove. In this case, dot remove combination dot size minus 1. Current index is bigger than I, right? So I is bigger than the current index that we're on, right? So let's check to see if nums at I is equal to nums at I minus 1. If that's the case, then we can just continue, right? Because we don't want to do a depth first search for the same element that is equal to the previous element, right? So, and the reason why we have current index I is bigger than current index is that we have to have room to check the previous element. And yeah, because like I showed you before, in this case, we always want to take the first element, right? We always want to take the first element instead of the second element. Second element usually have less options, and because the first element we already been there, we already have more options, we already exhaust all the options, right? And then we don't have to traverse this option anymore. So now if we were to run the code, and let's try with a few more examples. All right, so let's try to submit. And here you can see we have our success. So this is how we solve the combination sum number 2. Let's take a look at number 3. So find all valid combinations of k numbers that sum up to n such that the following conditions are true. So only numbers 1 through 9 are used, and each number is used at most once. So return a list of all possible valid combinations. The list must not contain the same combination twice. The combination might be returned in any order. So here you can see we have k. K is going to be the size of the combination, right? So in this case, k numbers that sum up to n. N is going to be the target, right, where we want to get the combination sum to be equal to, right? In this case, 1 plus 2 plus 4 is 7. So in this case, we can use numbers from 1 to 9 only. So we have 1 plus 2 plus 4, and there are no other valid combinations, right? We cannot have 2 plus 1 plus 4, or let's say we cannot have 3 plus 4, because in this case we need to have a size of k, right? So let's say we have another example where k is 3, n is 9, and in this case our target is 9, right? So in this case, this number right here, these numbers add up to 9, and these numbers add up to 9, and these numbers add up to 9. So in this case, we have total of three combinations. Now let's say if we have empty, sorry, not empty. Let's say we have k is equal to 4 and n is equal to 1. Then there's no other numbers that can add up to, to 1, right? In this case, 1 plus 2 plus 1 is not equal to 1, right? So what we can conclude based on those two examples is that if we have a situation where k is bigger than n, we can just return the list. Okay, so what I mean by that is, like, if k is bigger than n, we can just return result, right? And basically return an empty list of combinations, right?
if we have a situation where k is bigger than or equal to n, then less than or equal to n, then we probably have a chance that we can find a combination. But if it's less than, then we can guarantee that there's no combination. If we have a situation where like something like this, then what we need to do is we need to basically do the same thing that very similar to the combination sum, the previous combination sum problem that we did, right? We're going to iterate from 1 to 9, right? Or the current element, the current element to 9, because in this case we cannot have duplicate values, right? We cannot use 1 plus 1 plus 1. So in this case, the current value, the current element to 9, and then in this case we're just going to try all the combinations that we can have, right? We're going to have a depth first search method, right? We're going to pass in the current the current combination that we have so far, as well as the current sum, right? In this case, the current sum is 0, and the starting point is going to be is also going to be in this case the starting point is 1, right? So at the end we're just going to return a result, because after we've done that for search, that's what we're going to return, right? We have all the combinations we have, right? So we're going to have a depth first search method that takes a list of integer, and we're going to have sum, and the current let's say current element or current number. And what we're going to do is we're just going to have k and n going to be a global variable, right? So in this case, what we're going to do is we're going to rename them. So k is going to be the size, right? And n, I should say the target, right? The sum, right? The target sum size now is going to equal to k, and target now is equal to n, right? So let's see what we're going to do then. If the current sum, right? So we're going to define our base case. So if sum is actually bigger than the target sum, right, then we can just return. Our job is done, right? We don't have to continue to search anymore if the sum is bigger than target. And if the sum that we have right now is equal to the target, that means we found an option, right? In this case, we found an option. Then what we can do is we can just add the current combinations onto the result. So in this case, result.add, we pass in the combination, and then we can just return. So if the current sum is less than target sum, then that means that we can still have rooms to add integers onto our combination. So we're going to iterate. So in this case, we're going to have current, which is stand for current number. Right? Current number is equal to none. Okay. So while current number is less than or equal to 9, okay, we're going to increment the current number for each and every single iteration. And then basically what we're going to do is we're starting at 1. Remember, we're starting at 1, and current sum is equal to 0. So what we're going to do is we're just going to we're going to add the current element onto the combination. So combination.add the current num, right? We're adding the current number onto the combination. We're going to do a depth first search. We're going to pass in the current combination as well as the current sum, which is plus current num, right? And then we're just going to pass in the number. In this case, it's going to be current num plus 1, right? We're moving on to the next element because we cannot have duplicate elements. So after we've done that, we're just going to say dot remove com.size. So combination.size -1, right? The last element off of the combination that we have after we've done the backtracking. After we've done the depth first search, coming back, we can just remove the element, right? So let's try to run the code. and we notice that we got a yeah, another thing that I forgot to do is that we have to make sure that combination.size, right? So combination.size is must equal to the size, right? So if it's not equal to size, we cannot add this element onto it. And let's try with a few more examples. Okay, I think this is an easy question. So you can see here we have our 6